All right, section 10.3, polygons, perimeters, and tessellations. Okay, what are we going to do? We're going to do all of that. So first, some definitions. We have a polygon is a closed shape. Remember we talked about closed shapes when we were talking about triangles. And a polygon can have 3 or more line segments or sides. A regular polygon is a special type of polygon, regular polygon, where the length of each of the sides is the same and the angles of all the measures are going to be the same. The perimeter of a polygon, you add up the lengths of the sides. Here are some examples of regular polygons. These are regular polygons. Make sure you pay attention to that word regular. A 3-sided regular polygon, we call that a triangle. In fact, it's an equilateral triangle. A 4-sided regular polygon is called a quadrilateral. And we also call it a square. Okay. A 5-sided is called a pentagon. The most famous is in Washington, D.C. And 6 sides, we call that a hexagon. 7 sides is a heptagon. To be perfectly honest, I don't know of anything that would have 7 sides, but we have a name for it. It's called a heptagon. And 8 sides is an octagon. Let's see. By the way, where do you see an octagon? Probably on a daily basis. Stop sign is an octagon. All right, we have different types of quadrilaterals depending on their sides and their angles. So this quadrilateral is called a parallelogram. When we have a parallelogram, the opposite sides are parallel to each other. Okay, because the opposite sides are parallel to each other, that means that the opposite angles are going to be the same. And opposite sides are also going to have the same measure, like that. Both pairs of opposite sides are parallel and have the same measure. Opposite angles have the same measure. By the way, if we look at these figures here on this slide, this is also a parallelogram, this is also a parallelogram, and this is also a parallelogram because it meets the definition of parallelogram. Opposite sides are parallel, opposite angles are the same measure, and opposite sides have the same measure. So it meets the definition of parallelogram, even though that's generally not what we call it. Okay, rhombus. Keep in mind, we already called it a parallelogram, but this time all of the sides have to be the same length. Okay, all of the sides have to be the same length. We have another rhombus on the screen. That would be this one right here. Again, we don't generally call it a rhombus, but technically it is because it meets the definition. All right. A rectangle is a special type of parallelogram where the angles are all right angles. Okay, we call that a rectangle. Again, a special type of rectangle meets the definition of rectangle. All right, square, also called a regular quadrilateral, regular polygon. All of the sides have the same measure and all of the angles are 90 degrees. And then lastly, we have a trapezoid. There's actually different definitions for trapezoid, believe it or not. I just always assumed that there was one definition, when in fact there's two definitions, but we'll go with this one. It's a quadrilateral, has four sides, exactly one pair of parallel sides. So this side is parallel to this side, but these two sides are not parallel. By the way, the other definition, the one we're not going to use, is instead of exactly, they say at least one pair of parallel sides. If they say at least one pair of parallel sides, then technically all of these would be trapezoids, but that's not the definition we're going to use. Just throwing that out there for your information. All right. Fencing costs $5.25 per foot. Got to pay attention to the units. Diagram, that's in yards, so we got to pay attention to that. Find the cost to enclose the field with fencing. Well, this is a perimeter question. Anytime they talk about fencing, it's going to be perimeter. So what we have to do is we have to add up the sides. Now keep in mind this is a rectangle, which means that opposite sides have the same length. So this is 42 yards, and this will be 28 yards. Okay, so to find the perimeter, we're going to add up the sides. So we've got 42 plus 28, that's halfway around. So I've got this one and this one, got these two. Now I have to do another 42 and another 28, and that will give me the perimeter in yards, which is just the first step into finding the answer to this problem. So 42 plus 28 will give me 70, plus another 70 should be 140 yards. All right, 140 yards. Okay, so once we're done finding the number of yards, keep in mind that the fencing costs per foot. So we need to know how many feet this is, not how many yards. So we have to change 140 yards and we have to convert it to feet. If you were not aware, there are 3 feet for every yard. A couple different ways we can set this up. We could, since we know that there are 3 feet in every yard, we could multiply that. I'm going to use a calculator because I'm being lazy. 420 feet. The other way we can set it up is that we can use what's called unit analysis. And we know that there's 3 feet for every 1 yard. The advantage to doing it the second way is that we don't have to remember whether we multiply by 3 or divide by 3, because the way we set it up will automatically tell us whether we have to multiply by 3 or divide by 3. So in order for me to be able to cancel this unit, I need for my fraction here to have the yards in the denominator so that I can cancel my yards. So then I multiply these two fractions together. I end up with 420 feet. So either of these two ways will get you to the same answer. All right, so that's the number of feet, but our fencing costs $5.25 per foot. For every foot, we have to pay $5.25. So we're going to take 420 feet, and for every foot, so I'm going to multiply that by 525 and get $2,205 to fence my field. Yeah, see, they did it the second way. Yep. All right. Oh, and they did the cost the same way. $5.25 for every 1 foot. So my feet will cancel and I will be left with the dollar unit. Okay. All right, I'm going to stop here and pick up with another video.